Welcome to Srividya Academy, the go-to channel for special education in KCET, JEE and NCERT mathematics. I am thrilled to have you here. If you find my videos helpful, please hit the like button and subscribe to my channel. By subscribing, you will stay updated with my latest content designed to empower students like you. Join me on this incredible journey of growth and success. Remember, your learning journey begins here. Don't forget to share this video with your friends, classmates, and anyone who can benefit from specialized math tutorials. Together, we can create an inclusive learning community where everyone thrives. The common roots of the equations x cube plus 2x square plus 2x plus 1 equals 0 and x to the power of 2000 plus x to the power of 2002 plus 1 is equal to 0. This is a numerical value type question. Here we are supposed to find the common roots between the given equations. To that end, let us consider the first equation, that is x cube plus 2x square plus 2x plus 1 is equal to 0. Let us rewrite this as x cube plus 1, that is x cube plus 1 here, and let us take 2x common in second and third term. So we get 2x into x plus 1. So we have x cube plus 1 plus 2x into x plus 1 is equal to 0. Now let us use the formula for this first term, that is x cube plus 1. We know that a cube plus b cube is equal to a plus b into a square minus ab plus b square. Here a is x and b is 1. So we will apply the formula. We have x plus 1, that is a plus b, into a square is x square minus ab is x into 1 plus b square is 1 square, which is 1 here. So first term x cube plus 1 becomes x plus 1 into x square minus x plus 1, and let us write the second term as it is, that is 2x plus 2x into x plus 1, which is equal to 0. Now you can notice that there is a common term which is x plus 1 in both the terms. That is, in the first term we have x plus 1 here, and in the second term also we have x plus 1. So let us take x plus 1 common. So we get x square minus x plus 1 plus 2x. 2x minus x is plus x. So we get x plus 1 into x square plus x plus 1 is equal to 0. Now we have to find the value of x which satisfies this equation. Clearly x is equal to minus 1 is one root of this equation. And next, let us apply the formula for x square plus x plus 1 is equal to 0 to find the value of x, that is to find the roots of this quadratic equation. We know that ax square plus bx plus c is equal to 0. Then x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. We have a is 1, b is 1 and c is 1 here. So x is equal to minus b, that is minus 1, plus or minus square root of b square is 1 square, which is 1, minus 4ac, a into c, that is 4 into 1 into 1 by 2a is 2 into 1. So upon simplification we get x is equal to minus 1 plus or minus square root of minus 3 divided by 2. So minus root 3 is nothing but I root 3. So x is equal to minus 1 plus or minus I root 3 divided by 2. Therefore, for the given cubic equation, we got three roots, which is x equals minus 1 and x is equal to minus 1 plus or minus I root 3 divided by 2. We know that minus 1 plus I root 3 by 2 is omega. You can recall this is a cube root of unity. Similarly, minus 1 minus I root 3 divided by 2 is also a cube root of unity, which is omega square. So we have x is equal to minus 1, x is equal to omega, and x is equal to omega square are the roots of the given first cubic equation. Now we have to check whether these three roots satisfies the second equation, so that we will be able to find the common roots. Consider the second equation, x to the power of 2000 plus x to the power of 2002 plus 1 is equal to 0. We have seen that x equals minus 1 is one root of the first equation. Now let us put x is equal to minus 1 in the second equation. The second equation becomes minus 1 to the power of 2000 plus minus 1 to the power of 2002 plus 1, which is equal to 3. That is minus 1 to the power of 2000 is 1 and minus 1 to the power of 2002 is also 1, and we have 1 here. So this is 3, which is not equal to 0. Clearly x equals minus 1 is not a root of the second equation, because x equals minus 1 will not satisfy this equation x to the power of 2000 plus x to the power of 2002 plus 1 is equal to 0. Next, let us check for x equals omega. That is, let us put x equals omega in the second equation. So second equation becomes omega to the power of 2000 plus omega to the power of 2002 plus 1, which is equal to omega cube whole to the power of 666 into omega square. So you can observe here 666 into 3 is 1998 plus 2 is 2000. Similarly, omega cube to the power of 667 into omega is nothing but omega to the power of 2002. We are rewriting this omega to the power of 2000 and omega to the power of 2002 as omega cube whole to the power of 666 into omega square and omega cube whole to the power of 667 into omega. This is because we know that omega cube is 1, that is value of omega cube is 1. So omega cube to the power of 666 and omega cube whole to the power of 667 both are 1. So we get omega square plus omega plus 1. That is, this given equation, that is second equation, becomes omega square plus omega plus 1, and you can recall 1 plus omega square is 0. That is, x equals omega satisfies the second equation. So x equals omega is one common root of the given two equations. Now let us check for x equals omega square. That is, let us put x equals omega square in the second equation. That is omega square whole to the power of 2000 plus x to the power of 2002 becomes omega square to the power of 2002 plus 1. So upon simplification, this 2000 into 2 is 4000 here, and 2002 into 2 is 4004. So second equation becomes omega to the power of 4000 plus omega to the power of 4004 plus 1. This is nothing but omega cube whole to the power of 1333 into omega, and omega to the power of 4004 is omega cube into 1334 into omega square plus 1. So as before, this omega cube is 1, so omega cube whole to the power of 1333 is 1 here, so 1 into omega is omega. Similarly, second term is also omega square and plus 1 here. So clearly 1 plus omega square is equal to 0. Hence x equals omega square is a root of the second equation, and we have seen that omega square is one root of the first equation. Therefore omega square is a common root. So thus omega and omega square are the roots of x to the power of 2000 plus x to the power of 2002 plus 1 is equal to 0. So we can conclude that omega plus omega square are the common roots of the given equations. I hope you found this video from Srividya Academy both educational and enjoyable. If you did, please take a moment to show your support by hitting the like button and subscribing to my channel. Your engagement helps us to create more content and reach a wider audience. Thank you for being a part of this journey and I look forward to sharing more exciting mathematical explorations with you in the future. Thank you. Wish you all the best.